Hello and welcome to this video. In this video we're going to do an example question from the gravitational fields topic. So we're going to look at a specific case that I've seen come up quite a few times that has seemed to get students a little bit confused, mainly to do with how to set up the problem, not so much solving the problem. So it does get quite algebraic, so for any of you who are not fans of algebra, apologies in advance. But this is something that you will have to be able to do. So let's get straight into the question. So what the question will give you is usually going to be two bodies of some mass. Now I'm going to represent this as being two black holes, just to make it interesting. It could equally be two stars or two planets or two metal spheres or anything like that. But what I'm going to do, just to try and pique your interest a little bit, is I'm going to make these black holes. They have mass, therefore they will have a force of gravity that will obey Newton's law of gravitation to an extent. So let's just say I have two black holes, and this black hole over here, this one here, has a mass of 4m, okay? And then this black hole over here has a mass of just m. Okay, so we have two black holes. One has a bigger mass than the other, but they are massive, which means that they will have the force of gravity between them. Let's say that these are a distance d apart. So I'm not going to specify everything, so I'm leaving everything algebraic. In some questions, they will specify the distance and the masses. In some questions, they won't bother and they'll just ask you to come up with an algebraic expression. Obviously, the method is the exact same. You're just either substituting numbers or letters, but it doesn't really matter which way around you do it. And what the question will ask is, at what point or at what distance from the 4m black hole is the gravitational force felt by a test mass 0 newtons. So this is our question. We have these two masses. We're saying that this mass m is going to pull everything in towards it, coming in this way, and this mass m, this mass 4m, is going to pull everything in towards it going this way. So there must be some point between these two where actually the force that 4m pulls with must be the same as the force that m pulls with. And this is for a test mass. Now I've kind of been a little bit nice in this question and told you there's a test mass involved. This isn't always the case, but this is always your approach. You always want to say, okay, what if I had a positive test mass here, or if I just had a test mass here, what possible position would it be in where the force that it would feel from each of these stars, black holes, planets would be equal to each other. So that's what we're going to do. So the first thing we need to do is set some test mass. So I'm going to put it here, and I'm just going to call this distance x, because that's the one we want to work out. We want to work out the distance from the 4m black hole. So I'm going to call this x, and then we can say that this is therefore just d, which is a known constant, minus whatever we find this value of x to be. Now that means the force felt on this test mass by the 4m black hole will be g times the 4m times the small m divided by the distance between them squared, which is just x squared, and that must be equal to the force felt produced by the just m mass. So that's g times m times little m divided by the distance between them, d minus x, all squared. Now this comes down to the idea that we just need to solve this expression for x. So we just need to solve for x. Okay, and then as soon as we've solved for x, we have our solution. Okay, it's not an overly complicated thing to do. That's why sometimes these questions will only be worth 1 mark in a multiple choice section of the paper, but they will always have the same approach. These will also come up in electric fields and will follow the same process for those. But what we can see in this case now is from this expression, we want to try and simplify things. We want to try and make the answer to this as simple as possible. So we can see there's a g on both sides because that's a constant, so we can cancel out a g. We can see there's an m on both sides, so we can cancel out an m. And we can see there's a small m on both sides, so we can cancel out the small m. So now we're just left with 4 over x squared is equal to 1 over d minus x all squared. Now from this point, most people will rearrange and they will form a quadratic equation, and then they will solve that quadratic equation. And while that is a valid approach, it's not the easiest one. Save yourself the time. Notice here that I could just square root both of these sides. So if I square root this and I square root this, it gives me the equation. The square root of 4 is 2, the square root of x squared is just x, the square root of 1 is 1, and the square root of d minus x is just d minus x squared is d minus x. And so this is a much easier equation, and the better thing about this is linear, so I have no squareds involved, which means I'm only going to get one solution, which is the correct way to do this. In this case, if we were to do it quadratically, we'd end up with 2 solutions and we'd have to choose which one is valid. Now, if you do it by that method, you'll end up usually with a positive and a negative answer. And we would say, okay, we take the positive one because we know this is distance. We obviously can't have a negative distance. Then you just have that answer. But you can just square root it and then you only get one answer and you know for a fact that your answer is right. So now what we're going to do is multiply the d minus x up to here and multiply the x up to here. So I end up with 2 times d minus x is equal to 1 times x. I'm going to expand these brackets, so I get 2d minus 2x is equal to x. Add the 2x to this side, 2d is 3x, and then divide by 3, so x is 2/3 of d. Okay, so this means that in between these two black holes here, if I go exactly 2/3 of the way along, so I'm about here, this mass is not going to get sucked into this black hole or this black hole because these two forces are actually equal to each other, and it will end up being able to stay there forever, essentially. Okay, now sometimes you'll get a factor here that can't be square rooted easily. So for example, if this was instead 2 and not 4, the square root of 2 is going to be a decimal number. So I would say leave them in surd form. So surd form is just the square root of 2. And then you'll end up with the square root of 2 over 3d. Your answer will still be right, okay? So the algebra behind these questions will come up quite a lot. But this is one of the most common questions that I see students struggling with. So I thought I'd go through this, and thank you for watching.